Okay, so we are going to be moving on to Unit 3. So make sure you have your Unit 3 packet out. And we're basically going to take our concept of derivatives and we're going to just learn some more complex rules and do some more advanced derivatives. So a reminder, when we see like rules for differentiation, differentiation means like the process of taking the derivative. So in today's lesson, we're going to look at how to find the product, the derivative of the product of two functions. So if we look at this first example, right, 2x minus 3 and x squared minus 2x plus 1, that's a product, right? Product meaning to multiply. Now, so far, what we would have done is we would have just expanded these, right? We've rewritten it. And so, kind of off on the side, right? X squared minus 2x plus 1 times 2x minus 3, we would need to expand it. And then just line up 2x times 1 is 2x and just line it up underneath the x. Negative 4x squared would line up, and then positive 2x cubed. So we get 2x cubed minus 7x squared plus 8x minus 3. So this is in polynomial form, and now that it's in polynomial form, we can just apply the power rule. So we get 6x squared minus 14x plus 8, and that's our derivative. Now, basically this product is still, the same function, so that's the derivative. And what does the equation of f prime of x represent? Right, f prime of x represents the slope, and specifically the slope of the tangent line to f. And really it's for any x, right? Okay. So two men, Isaac Newton and then Gottfried Leibniz, basically both developed calculus. It's pretty interesting. They developed calculus kind of at the same time, but just in totally different areas of the world. And Leibniz had a definition for the product rule that we still use today. And so his definition is that if h of x equals f of x times g of x, so we see a product there, then h prime of x is equal to f prime of x times g of x plus f of x times g prime of x. And you'll see some textbooks write this slightly differently. Some textbooks will, write f prime of x g plus g prime x, g prime of x times f of x. They'll put the g prime of x first there. Let me try to clean this up a little bit. But it really doesn't matter the order you write it in. Again, other books will just flip. They'll flip this whole section with this whole section. And again, that doesn't matter. But what I like to kind of think of is using in words, okay? Is I like to kind of think of this means it's the derivative of our first times the original second plus the original first times the derivative of the second. So I always kind of use words when I think about my product rule. Right, so f prime is the derivative of the first times the original second is g of x plus f of x is the original first times the derivative of the second. So, just to kind of prove and illustrate that this does work and to practice, we'll do this same function. We'll take the derivative using this product rule. So here's our first function, and here's our second function. I always like to kind of bracket them out. It helps me. And I use a lot of parentheses here. So the derivative of the first, the derivative of 2x minus 3 is just 2. And then the original second, we're going to leave it completely alone. Right, that's what the g of x part is. So this is the derivative of the first, right, f prime, times the original second. So that was times g of x. So that was that first step, right? Then plus, now we're going to look over here at the second part of this. What are we going to do? We're going to leave the first one alone and multiply by the derivative of the second one. So again, I like to use parentheses for everything here. So the original first one was 2x minus 3. And then the derivative of our second one is 2x minus 2. And this is why parentheses is so important, is these will expand out. So we're going to expand 2x squared minus 4x plus 2. Then plus, here we're going to have to FOIL. So when we FOIL, I'll put this in parentheses again. 2x times 2x is 4x squared minus 4x minus 6x plus 6. Okay, and now we can just combine like terms. Whenever I combine like terms, I always underline my squareds one time, and then my x terms twice, and then my constants 3 times. So this gives us 2x squared plus 4x squared is 6x squared. Negative 4x minus 4x is 8x minus 6x would be minus 14x. And then positive 2 and positive 6 is plus 8. And then if we go back and we look up here, right, this is the same, which makes sense, right? We just did it a new way. So you can still expand it the way we did in the beginning, but now we have this new option available to us called the product rule. And the product rule is really important when we get into equations that cannot be multiplied out, cannot be expanded to turn them into a polynomial. So, for example, in the case of g of x equals x squared times sine of x, it would not be possible to write that as a polynomial, but we can still use the power rule, the product rule. So we're going to use the product rule to find the slope of the normal line. Now be careful about that normal line, right? That's the perpendicular. We have to flip it when x equals pi. So our first step would always be, if we're looking for the slope, would be to find the derivative. So g prime of x equals, and now we notice we have x squared times sine of x. That's a product. So x squared is my first term, and I use those brackets. Sine x is my second term. So the derivative of x squared is 2x. We leave this second equation alone. Then plus, now we're going to leave our first equation alone, and the derivative of sine x is cosine of x. So, g prime of x, now we can drop the parentheses, would be 2x sine of x plus x squared cosine x. And now we want to find g prime at pi. This would be the slope of the tangent line, would be 2 pi. Now, as a reminder, pi is over here on our unit chart, unit circle, -1, 0. So 2 pi times 0 plus pi squared cosine of pi will give us -1. So we get g prime of pi will be -1 times pi squared is negative pi squared, right? But we didn't want, that's the slope of our tangent line. And we wanted the slope of the normal line. So the slope of our normal line would be our perpendicular slope. So that would be, we flip the sign, and then take the reciprocal. So the negative would turn +1 over pi squared. So that would be the slope of our normal line. Okay. So, just a few more, just going through these for practice. I'll try to go fairly quickly with these. We just split, I like to put a little bracket there on my homework. F prime of x equals, now we take the derivative of the first one, so 4x plus 3, and then we leave the second one alone. So times x squared minus 3, then plus, now we're going to leave the first one alone. So 2x squared plus 3x times 2x. And now we're just going to expand these out. When we expand this one, we're going to do FOIL, and we get 4x cubed minus 12x plus 3x squared minus 9. And then here we just distribute. So we get plus 4x squared plus 6x, sorry, plus 4x cubed plus 6x squared. So again, I underline, this time my cubed I'd underline once, squared I'd underline twice, x I'll underline 3 times, and the number I'll underline 4 times. And so our only like terms here are for the x cubed and the x squareds. So 4x cubed plus 4x cubed is 8x cubed. Then 6x squared plus 3x squared is plus 9x squared. And then minus 12x and minus 9. And so this would be our f prime of x. Would be our answer that we would box. Okay. Now, the next one, as we do this, I do want to show us kind of a shortcut. And that shortcut is for f of x equals the square root of x. This is very common. And so far, we've always been writing this as a polynomial and then taking the derivative. So making that 1 over 2, 1/2, x to the negative half. Then taking the negative exponent, putting it back in the denominator. And then adding our square root back in. Well, the shortcut is to literally just memorize it. Okay, so and this is totally acceptable in the AP exam. It's something that many students memorize, and I'm going to ask you guys to memorize, is that when we start off seeing the square root of x, that we just immediately memorize that the derivative of the square root of x is f prime of x. So that is 1 over 2 square root of x. So basically from now on, we want to see, hey, as soon as I see square root of x, I have memorized that the derivative just is 1 over 2 square root of x. We don't need to rewrite it, we just memorize that. Okay? So kind of using that as a starting point, right, we're going to say this is our first term and our second term. So we said that we're going to memorize the derivative of square root of x is 1 over 2 square root of x. And then we're going to leave x squared minus 3x plus 2 alone. Then plus square root of x times 2x minus 3. Right, that's the derivative of our second one. So now for g prime of x, that's going to give us, right, I'm going to just distribute it. So basically x squared over 2 square root of x minus 3x over 2 square root of x plus 2 over 2 square root of x plus 2x squared of x minus 3 squared of x. And that's a pretty good answer, but I'm going to just kind of clean it up a little bit. So square root of x is x to the half power, so we can cancel out a half power here and here, so like minus 1/2. So 2 minus 1/2 is 4 over 2 minus 1/2 is 3 over 2. Okay, 1 minus a half is a half. Here our 2's cancel. And here, this is the first power times the half power. So 1 times half, when we're multiplying exponents we add, will be 3/2. So we'll see that in a second. So this is going to give us here x to the 3/2 over 2 minus 3x to the half over 2 plus 1 over square root of x plus 2x to the 3/2 minus 3 square root of x. Okay, and then that's a perfect answer for us. Oops, and I did mess this up. I forgot the half part, 3/2. It wasn't x cubed, it was x to the 3/2. So hypothetically, we could actually combine a little bit of like terms here, because if you see this guy has x to the 3/2 and x to the 3/2, and then this term is x to the half, and that's the same as a square root of x, but I'm going to go ahead and just leave our answer here. Okay. So next one, f of x equals x cubed times sine of x. So f prime of x, we're going to take the derivative of the first one, 3x squared, leave sine x alone, then plus, leave x cubed alone, derivative of sine x is cosine of x. And that's our answer, 3x squared sine x plus x cubed cosine x. And next one's very similar. Derivative of 3x plus 2 is 3 times original cosine of x, then plus 3x plus 2, and the derivative of cosine of x is negative sine x. So now we're going to just distribute 3 cosine of x plus, actually it'll be minus because of the negative, minus 3x sine x. We always put the number and the x in front, and then minus 2 sine of x in front of our trig. Then this next one's a little bit weird. It is product rule, but this part is product rule, but then the 3 theta is adding. So with adding, it's the same as what we did before, right, where you just do them separately. So the derivative of 3 theta is just 3. And then plus, now we're going to do our product rule. So the derivative of theta is 1, leave sine theta alone, and then plus, leave theta alone, derivative of sine theta is cosine theta. So if you notice the plus always acts, I think of it as a separator, right? The plus is a separator. Do the derivative of 3 theta on its own, and then do the derivative of the right side on its own. So this gives us 3 plus sine theta plus theta cosine theta. And then lastly, if we had the derivative of sine x times cosine of x, right? It's all just the same process. Derivative of sine x is cosine of x times cosine of x. And then plus, now we're going to have sine of x, and the derivative of cosine of x is negative sine of x. So be careful, this is not sine squared plus cosine squared where it cancels out to 1. This is just cosine of x times cosine of x is cosine squared x, and then minus sine squared x, and that's our answer. Some textbooks will kind of rewrite this using sine squared plus cosine squared x equals 1. But you'd have to replace, say sine squared x with 1 minus cosine squared x. So you get like, cosine squared minus 1 minus another negative would turn it to positive cosine squared x. And so you could end up with an answer of like 2 cosine squared x minus 1, but we're not going to worry about that. We're just going to leave it how it is boxed. So, practicing this, if you want to practice this on your own, you could pause the video and try it. So, g prime of t equals 2t, right, derivative, leave cosine t alone, and then plus, now let's leave t squared alone, times cosine of t. Okay. So that's our derivative, and so whenever we're writing the equation of a tangent line, we want to do x1, y1, and m. So x1 is pi over 6. For y1, we're going to plug in pi over 6 to the original. So that's pi squared over 36 times the cosine of pi over 6 on our chart is square root of 3 over 2. Okay, that's our cosine. So we're going to get basically pi squared root 3 over 72. Kind of weird, but it's okay. All right, and then for the slope is g prime of pi over 6. And so we're going to plug that in here. So that's going to be 2 pi over 6 times cosine of pi over 6 plus pi squared over 36. Oops, I messed this up. That should have been the original first one times the derivative of the second one would have been negative sine of t. There should have been a negative sine of t there. So times, now, sine of pi over 6 is 1/2, but the negative is going to make it negative 1/2. So it's the 2 and the 6 will cancel to pi over 3, times we said cosine of pi over 6 is square root of 3 over 2, and minus pi squared over 72. And this is going to give us pi squared root of 3 over 6 minus pi squared over 72, and that's fine for our slope. If we want to, though, we can multiply both sides by 12 on the left to combine to 12 pi squared root of 3 minus pi squared all over 72 and get in a one fraction. So this gives us our equation of our tangent line is y minus pi squared square root of 3 over 72 equals 12 pi square root of 3 minus pi squared over 72 times x minus pi over 6. There's a lot. And most of the time we're not going to get it that complicated, but just practicing. So when we use the product rule, there's a really, really valuable lesson that we're going to learn about it. And we're going to kind of see that right here. So, on page 193, we found f prime of x, right? And so, up there we had, okay, so here was our answer. And I even said, I was a little bit lazy and I didn't add those, but, if I lollipop the 2, right, times 2 times 2, we'd get 4 plus 1, so we'd end up with 5x to the 3 halves over 2. And we said a square root is the same as x to the half power. So the negative 3x to the half power and the 3 halves, 3x to the 1 half would also be like terms. And so if we lollipop this times 2, that's 6. And negative 6 and negative 3 make negative 9 x to the half over 2. And then plus, I'm going to just call this 1 over square root of x, or 1x to the half if I'm using all fractions. So it was a lot of tricky algebra. Now, if we did the same thing without doing product rule and just said this is x to the half times x squared minus 3x plus 2, and we just multiplied out, we get 2 minus a half, or sorry, 2 plus a half. We're adding 2 plus a half. 4 over 2 plus 1 over 2 is 5 halves. Minus 1 plus a half, right? 2 over 2 plus 1 over 2 is 3 halves. Plus 2x to the half. This is rewriting it. And when we take the derivative here, we just get 5 halves, x to the 3 halves, subtract 2 over 2, minus 1, minus 9 halves, x to the half, and plus, we said this is the one we can memorize, 2 times 1 over 2 squared of x, and the 2's cancel. So we end up very quickly with 5 halves, x to the 3 halves, minus 9 halves, x to the half, plus 1 over square root of x, or x to the half. And we notice these are the same thing. So kind of our lesson is that if it's easier, or if it's easy to rewrite as a polynomial, then our algebra is going to be way, way easier. So you don't have to always rewrite it as a polynomial, but it'll be a lot easier algebra when we do that. So essentially what that kind of means for us is that, we can, looking back up here, we can do any of these with product rule or with rewriting it as a polynomial. But generally, a lot of times the algebra actually works out easier if you can just expand it to the polynomial, especially with the radicals. Now, kind of same thing here for this guy. So we have 2x plus 3 times x minus 1 times x plus 3. And for me, it's a lot of times easier if we just expand it. So we just kind of FOIL the first one. And that's 2x squared minus 2x plus 3x minus 3 times x plus 3. And so that's 2x squared plus x, right? Negative 2x positive 3x minus 3 times x plus 3. And then we can even FOIL this. Now you could do product rule here if you wanted to do product rule here, but I'm even just going to expand that even out again. And so that's negative 9, positive 3x, positive 6x squared, and then negative 3x, positive x squared, and 2x squared cubed. So that gives us 2x cubed plus 7x squared minus 9. So that's g of x, and now this is a very easy derivative. We don't have to worry about product rule. Now, technically, there actually is a triple product rule. So just if you feel like you ever need it, I've really never seen it tested on the AP exam where you would have to use a triple product rule, but it does exist. And so, you know, the algebra would be a lot rougher, but what the triple product rule would have been would be take the derivative of the first one and then leave both of the second two alone. So it's kind of like, you know, we would do g prime of x would be equal to the derivative of the first one would be 2. Then we'd leave x minus 1 and x plus 3 alone. And then you do it, so that was for the first one. Then you leave the first one alone. You take the derivative of the second one, and you leave the third one alone. And then finally you would leave the first two both alone, and you would only take the derivative of the third one. And so you could FOIL all those out and expand it, and you'll end up with the same answer. So if you want to, you know, that is an option. You can do the triple product rule. But I like to, if it's easy to expand it to a polynomial, I like to do that. So now let's look at some graphs. So we're saying let p of x equal f of x times g of x. Okay, and then also let r of x equal x squared times g of x. So if g prime of negative 4 is equal to 2, they're telling us that g prime of negative 4, so you know the derivative at negative 4 is equal to 2, right here. The slope they're telling us is just 2. Then what is the value of p prime of negative 4? So what we can see is that at negative 2, sorry, at negative 4, g prime of, oh, that's my fault, g prime, so g of negative 4 is this point. That slope has a 2. Okay. So what we're going to do is we're going to say, first, I always write p of x, not p prime of x, but just going back to p of x. Right, what was p of x? We said it was f of x times g of x. Now, for p prime of x, that means that we're just going to literally write it the way the rule is. F prime of x times g of x plus f of x times g prime of x. Now, we're going to plug in negative 4. So f prime of negative 4 times g of negative 4 plus f of negative 4 times g prime of negative 4. So f prime of negative 4 is going to be the slope, the derivative at negative 4. And if we're looking here, the slope here of this line, it's a line, is down 1 over 1, right? Down 1 over 1, down 1 over 1. The slope is negative 1. So f prime of negative 1 is going to be negative 1. Then for g of negative 4, that's the y value, right? Not prime. G of negative 4 is the y value. So the y value here is 6. So times 6. Then f of negative 4, again, that's our y value. So at negative 4, our y value is negative 1. And g prime of negative 4, well, I can't really tell from the graph because it's a curve, right? It's curving. But they gave it to us. They told us it was 2. So times 2. This is negative 6 minus 2 is negative 8. Okay. And then in this next one, they're saying if r prime of negative 2 is already equal to 20, then what is the value for g prime of negative 2? So we're going to start off same way. We're going to start off with r of x, and it was x squared times g of x. And so now r prime of x will be the derivative of the first, 2x, leave the second alone, g of x, then plus, leave x squared alone, times g prime of x. And so what we're going to do is we're going to plug in negative 2. So r prime of negative 2 would be 2 times negative 2 would be negative 4, g of negative 4, plus negative 2 squared will be 4, g prime of negative 4. And now we're going to plug in everything that we know. Now this time we do know r prime of negative 2. We know that that answer is 20. We're not solving for it. They gave it to us. We're actually solving for g prime. Oh, these should have been negative 2. Right, negative 2 and negative 2. So negative 4 times g of negative 2. Well, g of negative 2, right, at negative 2, that's our y value. So it's negative 3. So negative 4 times negative 3 is positive 12. And then plus 4g prime of negative 2. Subtract the 12, we get 8 equals 4g prime of negative 2. Divide, and we get g prime of negative 2 equals 2. So the slope there is 2. So that's what is the slope of the tangent line? It would be, at x equals 2, it would be negative 2, it would be 2. Okay. Find the equation of the tangent line to the graph of p of x when x equals negative 4. So we're going to just use what we have up there. But just kind of practicing, right? x1, y1, and m. So x1 is going to be negative 4. Now, y1 is going to be p of negative 4. So we got to be careful with this. P of negative 4 is f of negative 4 times g of negative 4. We go back to the original, right? The original p of x, right up here, was p of x equals f of x times g of x. So we need to be careful with writing functions these way. It's kind of called composition. So f of negative 4 is the y value. So looking on the graph, we said the y value was negative 1 for f and positive 6 for g of negative 4. So negative 1 times negative 6 gives us positive 6. That correctly, right? Yeah. So negative 1 times, oh, positive 6, that's where I messed up. Negative 1 times positive 6. I knew in my answers I had a negative there. Right, the 6 up here is positive 6, it's above. So our y1 value is negative 6. Now our m, we already did our m. Our m was negative 8 from up above. So y plus 6 equals negative 8 times x plus 4. And that's our equation. Then same thing over here, right? x1, y1, and m. So x1 we know is given, it's negative 2. y1 I'm going to skip for right now, and m we already solved for was 2. So to get the y1, we're going to just plug in r of 2 and 2, right? It was x squared times g of x. So x squared, 2 squared is 4, right? And then g of 2 is the y value at 2. The y value at 2 was negative 3. So we get this as negative 12. So we'd have y plus 12 equals 2 times x plus 2. And so that's our equation of our tangent line. So just kind of reviewing from last chapter. Okay, and then finally we could do these with a table, right? So maybe instead we have a table. Now, anytime we see the word estimate, we have two estimates right now. We have the tangent line estimate, which we write a tangent line, and that's for estimating f of a number. So f of a number, we always use the tangent line. That's where we write a tangent line and then we plug in the value. Well, if we're going to estimate f prime of the number, that's where we do the y2 minus y1 over x2 minus x1, kind of go back to math 1 slope. So we'll say f of f prime of 3.5 is approximately, and you can write y2 minus y1 over x2 minus x1. I like to get us practicing to write this the calculus way. So for, we use the values of x right around 3. So 3.5 would be kind of in between 3 and 4. So f of 4 is our y2 minus f of 3 is our y1. And then 4 minus 3, that's our x2 minus x1. So f of 4 is 1 minus f of 3 is negative 2. And then 4 minus 3 is 1. This gives us 1 plus 2 is 3 over 1, so we get 3. So our slope is approximately 3. So that's kind of review, but f prime of 3.5 would be approximately 3. Now, if q of x is 2f of x minus 4g of x, now this is a negative, a subtraction. Just like I said, adding, when you see an addition sign, this is just a separator. We're not doing product rule, we're just separating it. So it would be the derivative here. Q prime of x would just be, the derivative 2f of x would just be 2f prime of x. The derivative f on its own is just f prime. Then minus the derivative g on its own is g prime of x. And the 4, it's a coefficient. It's just like what would be the derivative 4x would just be 4. It just stays, right? 4 times. So it's just multiplying. So now if we're asked what would be q prime of 4, well, q prime of 4 would be 2 f prime of 4, and I like to write it this way. You don't have to necessarily show this step, but I like to. So this gives us f prime of 4 is going to be negative 4. So 2 times, oops, I messed that line up. That was for 3. We're doing 4. F prime of 4 would be 2. So 2 times 2 is 4. And g prime of 4 would be negative 3. So negative 4 times negative 3 would be plus 12. So we get q prime of 4 would equal to 16. So again, this was from f prime was 2 and q prime was negative 3. I kind of didn't write that step because I was running out of room. But basically it was the 2 times 2 minus 4 times negative 3, and we got 16. So now, this case, we do have a product. And I always just group if there's a coefficient, I always just group it with my first product. So p prime of x, the derivative of the first one, the negative 2f would be negative 2f prime of x. If you want to use brackets here, some teachers will use brackets, times the original g of x. Then plus, now we're going to leave the first one alone, negative 2f of x, times the derivative of g is g prime of x. So now, for p prime of 3, right, you would just rewrite all of that, but replacing the x with a 3. And again, you don't have to write this step, but I like to. It kind of helps me to keep everything organized. Right. So f prime of 3, I'm going to kind of erase some of this. So we're going to be on the 3 line is that second line. So f prime of 3 is negative 4. So we're going to have negative 2 times negative 4 is going to be positive 8. Times g of 3 is the original, is 8 times negative 3. Then plus, so now negative 2 times f of 3. F of 3 was negative 6. So negative 2 times, was negative 2. Negative 2 times negative 2 is positive 4. And g prime of 3 is 2. So we get negative 24 plus 8, which is negative 16. So p prime of 3 would be negative 16. If you're struggling with some of these, just try to erase it and try it again on your own. They're really important, and when you do them a second time, they're actually really easy. So this last one is to find the equation of our tangent line. So x1 is going to be negative 1. For y1, we're going to plug that into the original. So we're going to do v of negative 1 is negative 1 cubed times f of negative 1. Negative 1 cubed is negative 1. And f of negative 1 is 2. So we get negative 2, that's our y1. And for the m, well, before we can do the m, we always have to take the derivative. So what we'll have to do is we'll have to say, okay, what is v prime of x? Right? And I'm going to do this down here because we'll have more room. V prime of x, this is product rule. 3x squared. I use brackets because, the double parentheses. But you don't have to. And then times x cubed times, then, oops, I did the derivative of both. This f prime of x should have been f of x, right? Derivative, and then original. Then plus original times the derivative. So that's how it should be written. And so now we can just plug in negative 1 everywhere. And since I'm running out of room, I'm not going to rewrite it. I'm just going to plug it in. So negative 1 squared is positive 1. So this is going to be 3 times f of negative 1. We just looked at f of negative 1 was 2. Then plus negative 1 cubed is going to be negative 1 times f prime of negative 1 is going to be 1. So this is 6 minus 1, which is 5. So that gives us 5. So then our overall answer will turn into y plus 2 equals 5 times x plus 1. Okay, and then very lastly, we have kind of this longer one. And it's scary at first, but if you use a highlighter or you just kind of do what I do and break up where is the actual multiplying happening. That's where we're having the multiplying, right? The multiplying's in the middle, right? We said the pluses you kind of ignore, they're just separators. So k prime of x will be equal to the derivative of the first one will be 2f prime of x, right? The plus 3's derivative is just going to go to 0, right? The derivative of the 3, it goes away. Then times the original second one is 3 minus g of x. Then plus, now we're going to leave the first one alone. So 2f of x plus 3 stays alone. And the derivative of the second one, now be careful with that negative symbol. The 3 goes to 0, so it's kind of like 0 minus g prime of x. Or a lot of you guys will probably just write negative g prime of x. You'll drop off the 0. So now, for k prime of 3, we're literally just going to plug in 3 everywhere. So 2f prime of 3 times 3 minus g of 3 plus 2f of 3 plus 3 times negative g prime of 3. And again, if you skip writing this step, it's okay. I like to, just to help me really organize everything. So f prime of 3, right, we're in that middle line again. F prime of 3 is negative 4. So 2 times negative 4 would be negative 8 times 3 minus g of 3. Okay, g of 3 is negative 3. 3 minus negative 3 turns to positive 6. And then plus, so 2f of 3. So f of 3 is negative 2 times 2 is negative 4. So that's negative 4 plus 3 is negative 1. And times negative g prime of 3. Negative g prime of 3 is negative 2. It might be a good idea to show a little more work than this to kind of actually show it out, like 2 times 4 and like 3 minus negative 3, and actually show out your work. 2 times negative 2 plus 3 times negative 2. But however, as long as we get to the right answer, I don't quite care how many steps we're showing, as long as the main step that you absolutely need 100% is you need this step written with the x's. Then after that, however you plug it in, you really just need some evidence that you plugged it in, and then you got to your answer. So I know it's a long video, but we went through a lot, right? We learned the product rule, and then we have some examples with graphs and some examples with a table, and then just quite a few examples actually doing it analytically with an equation. So when you get to your homework, right, kind of have those pages start. 114 is our examples for equations, 116 is our examples for graphs, and 117 our example for a table. And then stop me before class if you want to review any of those. But on the homework, we're going to be expected to do rewriting it as a polynomial, but then using it with product rule, doing some analytically with the equations, and then doing one with the table. And we don't have any with the graph for this homework, but we will have some in the future.